So this is the first problem of today's Div 3 contest. And in this problem, we are given that Vanya and Volva are playing a game and players are given an integer n. And on their turn, the player can either add 1 to the current integer or subtract 1 from the integer. Now, the players take turns and Vanya starts. If after Vanya's move the integer is divisible by 3, then he wins. Otherwise, if 10 moves have passed and Vanya has not won, then Vova wins. So we are given an integer n and we need to determine who will win if both play optimally. So this is a very simple problem. See, if we look at, let's suppose these are the numbers on the number line. So let's say this is 3, 4, 5, 6. Like I'm not writing numbers which are after 6 and which are before 3, but we can see that every third number is divisible by 3, right? But after, see, if Vanya starts, like if Vanya had this number, then he can do a -1 and he'll end up here, so he has 1. If he has a 5, then he can add +1 and he'll end up here, and that number is also divisible by 3. So, but okay, this is fine that if any of 4 or 5 is there, then Vanya will win. But what if the number was 3? Then Vanya needs to, like, there are only two types of operations that he can do, right? Either add 1 or subtract 1. So if he does +1 or -1, he'll either end up here, the number will be this or this. So now the optimal operation or optimal move for Vova is to move the number back to multiple of 3. So if the number is already a multiple of 3, Vanya cannot move. Otherwise, Vanya can always win. If the number is not a multiple of 3, if the number is already a multiple of 3, then Vanya will not be able to win. So I hope this is clear, right? Yes, no?
Can you repeat, please?
Okay. See, in this, we have, like, in each operation, either they can do +1 or -1. So after Vanya's operation, if the number is divisible by 3, then Vanya wins. Otherwise, Vova wins if 10 such kinds of moves have taken place. See, if the number was initially, it was either 4 or 5, that is, it was not divisible by 3, Vanya can always win because every third integer is a multiple of 3. So if it is 4, Vanya can shift the number to 3, that is, do a -1. If the number was 5, Vanya can shift it to 6 by adding +1.
Okay.
And by this, I mean that if n modulo 3 is 1, then this is true. If n modulo 3 is 2, then also Vanya can win by adding +1 to this number and by subtracting 1 from this number. But if the number was divisible by 3, then Vanya will never be able to win, because after one operation, the number will either be, like, if it was 3, it will either be 2 or it will be 4. And Vova will just undo what Vanya has just done. Is it clear now? Is it clear? Yes, no?
Yes.
Okay, so I'll show you the implementation. So this is the implementation. In this, I have just taken, like, if n was divisible by 3, then output second player has 1, otherwise the first player wins, that is Vanya. So going to the next problem. So in this problem, we are given that Alex is participating in filming another video with the BR Meest, and basically the problem is that there are n boxes arranged in a row, and we can choose any integer k which divides n, and then, like, let me explain the problem statement here. So the problem is that we are given n boxes, and let's say right now n is 4, n is 8. So we can choose something like k, which divides 8. So we can either choose 1, 2, or 4. So let's say I'm choosing 4, 2. So these are the boxes. Like these two boxes will go in the first truck. These two boxes will go in the second truck. These two boxes will go in the third truck, and these two boxes will go in the last truck. So there are 4 trucks. So we have to maximize the difference between, let's say this truck is having a total weight or the total value of these boxes as something as 60, and this one is having as 50. Like 50 is the sum of these two boxes, 10 is the sum of these two, and 20 is the sum of these two. So we have to maximize this value, which is maximum minus minimum. Maximum minus minimum, that each of these trucks is having. So this is the 60, which is maximum, and the minimum is 10. So we have to choose a k, like for this n equals to 8, I have 3 options, right? So I have to choose a k optimally such that this value is maximized. So first of all, is the problem statement clear? Yes, no, anything? Or is anyone
Yes.
having any doubt? Okay, it's clear. Now, the only thing, like I think the problem can be solved in an easier way. But what I did, see, usually a number n can have at max the number of divisors. Like if you want an estimate or a upper bound for this, or a like a what is a limit. So it's approximately equals to n to the power 1 by 3. It's not exactly equal to, but it's a rough estimate. Like the number of divisors, any number n, it will be close. Like maximum number of divisors that a number can have is n to the power 1 by 3. So what I did, I found the divisors for each number between 1 and 10 to the power whatever. Like I think it is 1.5 into 10 to the power 4 or 5. 1 to the, like this is 1.5 into 10 to the power 5. So found the divisors for each of these numbers between 1 and n. And then what we can do, like we are given some array in input. So for that array n, for n, we will find all the device for all of the divisors. I can do the same thing. Like these, all of those are my like possible values of k, right? So I'll brute force. It is just a simple brute force. Like if n was 8, then I will try first for k1, then I will try for k is equals to 2, then I'll try for k is equals to 4. So for all these divisors, I'll try and find what is the most optimal answer. And when my k is 2, what do I need to do? I need to do like find the sum of every window of size 2, and then pick the maximum, pick the minimum, and your answer is nothing but maximum of answer or this value. That is maximum value in of the any of these windows and minimum value of any of these windows. And my k will be, like I'll iterate brute force. So by the way, what will be the complexity? How many divisors there are? N to the power 1 by 3. And for each divisor, I iterate through my array. So that gives me an extra n. So n to the power 4 by 3 is the complexity. Is it making sense? Yes, no? Like just brute force. Is it making sense? Yes, no?
Yes.
What about others? Like, was there anyone who did this problem other than this manner? Like, other than this method? Or like you also solved this problem like this only?
I did this problem using kind of like prefix sum, and then I actually fixed like I iterated over the number of boxes I can take. Like if I will be taking one truck at a time, if I will be taking 2 trucks at a time, and
Okay.
at max I can take n by 2 trucks.
Okay, so you iterated from 1 to n by 2.
Yes.
So I think this will give you TLE. Your complexity is n into this thing, right? N by 2. So it is n square.
Yes,
Yes.
kinda, but like I used prefix sum, like already computed everything,
But
pre-computed.
still you are having two loops, right? First loop
Yes.
is running from 1 to n and the second loop is running from 1 to n by 2 like this, right?
Yes, yes.
So probably your solution will, like, I'm not 100%, but probably your solution will get hacked. Like the test cases that are like given during the contest are pretty weak, usually in a
Okay.
div 3 contest. But I'm pretty sure that an n square solution will give a TLE for this problem. But anyway, so let me show you, like I'm not 100% sure about my solution also, but still I'll show you the implementation. So this is like a simple sieve method for finding for each number how many, like what all divisors it has. So since n is around 1.5 into 10 to the power 5, I have just done a sieve method. And then, like, is anyone having any doubt in this? This is how you compute primes, by the way. Like if you want to know between 1 to n, which what are primes and which all are not primes. So this is sieve. And then for like for every divisor of n, I'm doing this brute force. So I have a minimum, mm minimum, and mm maximum. So these two are the minimum sum of the window of size d and maximum sum of window of size d. And by the way, this is not any random, like you might think if I have four, so these are the two windows that I'll consider, not this window, okay? Not every two sized window. So because trucks will, like first truck will take these two boxes, second truck will take these two boxes. No truck is going to take these two. That's why. So mmmin and mmmax will give me the maximum sum of those windows, minimum sum of those windows. And this is the simple implementation. How to do that? I am using accumulate. So by the way, don't get confused. Like using these two, you might think like accumulate also works in O of n, and this also works in this. But like this is getting incremented by d every time, and this is like getting the sum of size d. So overall, the complexity of this is O of n. This is maximum, minimum, and again, my answer is maximum of answer and maximum minus minimum for this d. Finally, I can print my answer. So is it clear? Is it making sense? Yes, no? Is there any doubt in this? Like if you're not having any doubt, you can just write in the chat or okay, this thing. Like you don't actually have to like copy or like take a screenshot or try to remember this. I'll share the quotes afterwards. Is it clear? Okay, so let's go to the next problem. Okay, but like I think the previous this problem might be having an easier solution because first of all, it's a division 3 second problem, and I think I have kind of over implemented it. And plus, like I'm not 100% sure like it won't get hacked, but like this is my intuition that and I'm like it should work probably. So this is the problem C, and in this problem we are given that so we need to find the sum of the longest, like the we need to find the maximum sub of any subarray which is having all the elements that, like all the consecutive elements should be of different parity. So like in this, like so let's suppose if you're considering this subarray, the parity of these two elements should be different, the parity of these two elements should be different, the parity of these two elements should be different. What is meant by parity? If this is odd, this should be even, then the next element should be odd, and the next element should be even. If I'm considering the so you have to find maximum sum of any maximum sum of any subarray. So how to solve this problem? First of all, what does have you solved this kind of problem? You're given an array A and you just have to find any like the maximum sum subarray.
Yes, it's kind of maximum subarray sum problem, kind of.
Yes. So perfect. This is cadence algorithm. So how to do that? You have a sum variable, you have an answer variable. Each time you add like to your sum, you add A of I. And when your sum gets less than 0, you can just update your sum as 0. And in each iteration, your answer is nothing but maximum of answer comma sum, right? This is cadence algorithm. Now this problem asks us exactly the same thing. The only thing is we cannot have two elements that are having the same parity. So what we do here, when sum gets less than 0, we'll add one extra condition that if the two consecutive elements are having the same parity, we'll make our sum again 0. Why? Because if let's say this is my current I and the next position is also having the same parity, I'll make my sum 0 here. Why? Because everything that was before this thing, like everything which I got before this now cannot be included in a subarray which will be having this element. Like what we do in cadence algorithm, if you look closely why we are doing sum equals to 0 and why we are adding, we are basically trying to end our subarray at I. If you are currently at I, we are trying to end our subarray at I, and whatever the position was the last position at which we made our sum 0, let's say this was the place where I made my sum equals to 0, because at this point my sum was less than 0. So it basically means that if I have taken these values also, my sum whatever sum I got in this part would be less if I took this thing. Why? Because the sum of this part is less than 0. So basically this means at the ith position I'm trying to end my array, and up till this is profitable or is optimal. So here also, if let's say if I have this extra condition, if I can maybe make my sum 0 here. So this will be my starting point. Why? Because these two elements are having the same parity, so I cannot include these. So instead of just having this check, I can add an extra check, or if the parity is same, make your sum 0. Is it clear? Like same as cadence algorithm. Is it clear? Yes, no? Or is there
Yes.
any doubt? What about others? Is anyone having any doubt in this? Okay, it's clear. So in each, like this is the exact same cadence algorithm. And in this, like this thing is okay. I've taken n as input, array A as input. Answer is initially minus 118. Why answer is minus 118? Why you shouldn't initialize your answer as 0? Because in the problem statement, it's given that we have to choose any non-empty subarray. So it's possible that the final answer can be negative also. So don't take your answer as 0. So answer is minus 118, sum is 0. Now iterating through the elements, add AI to your sum. Now you're trying to end your subarray at ith place. Answer is maximum of answer and sum. Now check if I is less than n and the next element is like the next element's parity is same as the previous element. Why I have done this? This is basically the absolute value of AI and the absolute value of AI plus 1. You can also use F absolute or maybe absolute. You cannot use F absolute because that will be a double. That is a float that gives you a floating point. So you cannot have a modulo of it, but you can convert it to integer and then take a mod. So like you can use absolute also, absolute function in C++, but I have done this thing. This is also same as absolute function. So maximum of this thing and maximum of this thing. If the parity of those is same, no, absolute doesn't return double. f absolute. That means this thing, this returns. Now, if the parity of these is same, sum is 0, and otherwise if sum is less than 0, again sum is 0. Finally, you can print answer. Is it clear? Okay. So going to the next problem, we are given that Yarik is a big fan of many kinds of music, but Yarik loves not only listening to music but also writing it. Now, he likes electronic music most of all, so he has created his own system of music notes, which, in his opinion, is best for it. Now, since Yarik also likes informatics, in his system, notes are denoted by integers of 2 to the power k, where k is more than or equals to 1 and is a positive integer. Now, but as you know, you can't use just notes to write music. So Yarik uses combination of two notes. The combination of two notes A, B, where A is 2 to the power k and B is 2 to the power l, he denotes by the integer A to the power B. So basically 2 to the power k to the power 2 to the power l. So I'll explain this in a moment. Now, for example, if A is 8, which is 2 to the power 3, and B is 4, which is 2 to the power 2, A to the power B is 8 to the power 4, which is 4096. Now, it's need to be noted that different combinations can have the same notation. Basically, 8 to the power B, you can get 4096 by writing it as 64 square also. So in this case, 64 is nothing but 2 to the power maybe 2 to the power 6, right? And this B was 2 to the power 1. So in that way also you'll get 4096. I'll explain this also in a moment, what I just said. So now, first of all, Yarik has already chosen n notes that he wants to use in his new melody. And however, since their integers can be very large, he has written them down as an array A of length n. Then the note I is bi is equals to 2 to the power ai. The integers in array A can be repeated. Now, the melody will consist of several combinations of two notes. Yarik was wondering how many pairs of notes bi and bj, I less than j, exist such that the combination bi bj is equals to combination bj bi. In other words, he wants to count the number of pairs ij such that bi to the power bj is equals to bj to the power bi. So first of all, let me explain the problem set. See, we are given some array A values. A note is something like this. Note basically is 2 to the power A3. The indexing is from 1. Okay. Now, this is a note 2 to the power A1. This is a note 2 to the power A2. This is a note 2 to the power A3. Now, as we have seen, a note is, let's say A3 was A3 was 8. No, not 8, 3. So, and A2, this A2, A3 is 3 and A2 is, what we can write it. Let's say it is 2. So this note is 2 to the power 2. Now a combination of these two will be, if I combine, let's say 3 and 2. So I'll get 2 to the power 3 to the power 2 to the power 2. So this is nothing but 8 to the power 4. This is nothing but 8 to the power 4 is 64 square, 4096. Is it right? Can someone just quickly check? Yes, no, is this thing right? Whatever I have written. Okay. So now let's say here the value was 6 and the value here was 1. So this note was 2 to the power 6, this note was 2 to the power 1. So I can combine these two also. So 2 to the power 6, 2 to the power 1 will also give me 4096 because it is 64 square only. So basically that, like, the problem has already mentioned that there can be two different combinations that will give me the same value. Now what we need to do in this problem statement is, we are given this thing, an array A. We have to count number of ij's such that 2 to the power the value at ai, to the power 2 to the power the value at aj is equals to 2 to the power aj, 2 to the power ai. We have to count this thing where I is less than j. So we have to count these kinds of ways. So first of all, can someone tell me, if I have this thing 2 to the power x to the power y, you know what this is? This is 2 to the power x into y, or anything like, let's take any base to the power alpha to the power beta, complete thing beta. This is base alpha into beta. Is anyone having, like, this is a maths formula. You can try this thing out. 2 to the power 3 to the power 2. 2 to the power 3 is 8. 8 square is 64. 2 to the power 6 is also 64. Okay. So basically, is this thing clear first of all? So 2 to the power xy is nothing but 2 to the power x into y. So can I not rewrite this statement as 2 to the power ai into 2 to the power aj? This should be equals to 2 to the power aj into 2 to the power ai, right? I have to count number of pairs ij such that this thing is right and I is less than j. I have to count ij, these pairs, right? Now the base here is same, the base here is same, so the powers should be same, right? So ai into 2 to the power aj should be equals to aj into 2 to the power ai. So I have to count number of pairs such that I is less than j and this thing is true, right? Yes, no? Everybody is, like, understood whatever I have told till now, right? So now first of all, if I take this, so I have to count number of pairs 2 to the power aj divided by aj. So right now, let's say if I'm at currently at jth position, so I need to I need to, if I am at currently at jth position, let's say for every j I need to add I less than equals to j, for which this thing is true. This basically this factor is same. So tell me one thing. If array A is having integers, right? So let's replace aj with 3. So for 2 to the power 3 divided by 3, okay, this will be like 8 divided by 3. You can never get this exact factor for any other value. Why? Because if you replace this with 4, the factor will be bigger. 2 to the power 4 divided by 4 is nothing but, what is this? 4. Now replace it with 5. So you'll see, like, this will grow exponentially as this power will grow. 2 to the power 5 by 5 is equals to 32 by 5. 2 to the power 6 by 6. Maybe it won't grow exponentially, but it will, like, you can actually draw the graph on Desmos or any, like, any online platform. You can draw the graph of 2 to the power x by x. Do you want, I can show you the graph. How many people actually want to see the graph of 2 to the power x by x? Like how the values will go. Okay, everybody, like, if no, like, actually you can also check this out, but if, like, majority of the people want, I can show you. Otherwise, it's like, it will be like a waste of time if nobody wants it. Okay, let me see. Okay, this is a hyperbola. Okay, so like you see, okay, this is exponentially only. So as x values will increase, these values will also, like, for any value more than 3, like for x equals to 3, you won't get, like my point was, if you see this, for any value of more than 3, you won't get this ratio same. Like this, like the ratio that you're getting for 3 is only unique to 3. The ratio that you're getting for 4 is only unique for 4. Like that is clearly visible by this. Like you can get this value, this is the value, right? This is the y value. You can get that value, exact value, but that value you'll get for less than, this is 1, right? This thing is 1. So you can get that value for at maybe, like if you look at this, you can get this value at 2 points, at x equals to 0.5 also, and you can get that value at x equals to 5, like this, or maybe x equals to 5, like you're getting this value, right? At x equals to 5, you're getting 6.4 as the ratio, and you can get the 6.4 ratio maybe at around 0.176. But this second value 0.176 is never possible because it is not an integer, it is less than 1. So for every value, first of all, more than 2, for every value that is between, after 3, you are getting a ratio which is unique to that only. So there is only one ratio which is repeating, which is for 1 and 2. Like for 2, the ratio value is 2. For 1, the ratio value is, what is the ratio value for 1? For 1, it will be 2 only. See, for 1, the value is 2. For 2, the value is 2. Why? We can plug in the values and we can get the values from here also. See, ai or x 2 to the power x divided by x. If x is 1, you'll get 2 to the power 1 divided by 1. If x is 2, you will get 2 to the power 2 divided by 2. Both will give you 2 only. So this ratio is same only for 1 and 2, and for all the other values the ratio is unique. So what I wanted, I wanted for every j, I wanted to count how many i's there exist which are less than j's, such that this is equal, right? This is equal. So first of all, if aj, for every j, I want to count the number of pairs for which this thing is equals to 2 to the power ai divided by ai. So for every j, I wanted to count these kinds of i's for which this thing is true. So now if aj is more than 2, then I just need to, like, I just need to count how many numbers are equals to aj in the prefix of, like, in front of this position, right? So in my answer, I'll add this much. Now, irrespective of this, like this is also valid for 1 and 2, I can do this every time. But if my current element is equals to 1, then I also need to add in my answer the number of elements which are 2 in prefix of this. Why? Because the ratio of 2 and 1 is giving me the same value. So count is nothing but the number of times this element has occurred in the prefix or in front of this positions, the current position, which is j. Count of number of times, if aj is 1, so number of times 2 appears. And if aj was 2, then in your answer you need to add count of 1. And finally, like, this thing is always added, this thing, like, because the ratio will be same only. So is it clear? Finally, we can print our answer. Is anyone having any doubt? Like, can you like unmute and let me know what is the thing that you have not understood? Like, let's say we are iterating our j from 0 to n. So if you want the number of pairs I and j such that this condition is true, so for every j, it is same as saying for every j, you need to count how many i's there exist such that I is less than j and this condition is true. So for every count, if count is giving me, count of aj is giving me how many times this element has occurred in the prefix Like in the prefix, I mean if j is this, how many times this aj occurs in this part. So that is my i's, right? Yes, how many same values. So let me show you the implementation. So this is the implementation. First, I have taken n as input, then I have taken array a as input. So this is my map. So first of all, I'm iterating through my array. I'll add how many times this element has occurred, because the ratio for all of those values will be like 2 to the power those values divided by, like let's say if current element is e, 2 to the power e divided by e is same for those positions and these position. Otherwise, if e is 1, then I can add this also. If e is 2, then I can add this also. Finally, I can print my answer. So hopefully this is clear, like why this is always okay and why I'm adding this extra here, because the ratio of 2 and 1 for elements 2 and 1 is also same. Is it clear? Okay, perfect. So let's go to the next problem. So the next problem is that Vlad found an array A of n integers and decided to sort it in a non-decreasing order. Now to do this, Vlad can apply the following operation any number of times. Extract the first element of the array and insert it at the end. Swap that element with previous one until it becomes the first element or until it becomes strictly greater than the previous one. So now we just have to determine the minimum number of operations required to sort the array or report that it's impossible. So let me take this example only. So what we need to do in this problem, okay, so see, let's suppose we had an array 4, 3, 1, 2, 6, 4. So in each operation, one operation is first take this element, put it at the back, 3, 1, 2, 6, 4, 4. Now you need to shift this element forward till you find the element which is strictly less. So see, for 4, 4, it is not less. So this 4 will come here. Then 4, 6, 6 is not less. So this 4 will come here. Now once this 4 reaches here, this 2 is strictly less. So the array will become, after one operation, it will become 3, 1, 2, 4, 6, 4. Now this is the 4 which was here. Okay. Now in next operation 3, you can shift this, like this 3 will reach 1, 2, 3 here. This is the 3, 4, 6, 4. Is it making sense? Like how the elements are going? In next operation, if you do 1, 2, 3, 4, 6, 4, once you get this array, if you have this one, then this element, like this will go at the first, it will go at the back, 2, 3, 4, 6, 4, 1 will come here. Now you need to shift this one forward. You need to swap these elements until it either reaches the front or it is like strictly more than the previous one, but it will never be strictly more than previous one because one is the least element in this array. So after one operation, one will again, like you'll get the same array. Did you get what I said? Okay. So one thing is clear, once we have the least element at the front, if there are like some more ones, then also nothing will change because we need a strictly smaller element than one for one to stop anywhere in between. One will stop anywhere here if this element was less than one, if this element was less than one, if this element was less than one. So otherwise one won't stop anywhere. Like it will come to the first place only. So the least element will never like once you get the least element at the front, the array won't change. So the point is, and everything that is before the least element, those elements will always get in their sorted position only. Why? Because those elements will stop. Like first they'll go at the last place, then they'll keep on coming in front, and they will eventually stop before getting swapped with the element which is more than them, right? Yes, no. Like let's say this is the array. You have the least element here. So these two elements will anyway get to their sorted position only, like to the first place, which is not more than them. Like let's say this is 3, this is 4, this is like these things can be anything, but this is 2. So this 3 will stop here. So the only point is, if this thing is sorted, like anyway, you won't be able to change the relative order of elements which are already present. Forget about 3, forget about these two elements. All the elements which are present already here, you cannot change their relative order. Why? Because first of all, once you reach this element, nothing will change. The array won't change. And plus, the relative order of these elements won't change. But if this is, let's say this was sorted already, this part is sorted already. So this 3 will also get into its sorted position only. This maybe, let's say this is 2, or maybe this is 4, anything. These elements will, like, it doesn't matter whether this part is sorted or not. If this part is sorted, this is the least element, then your final array will be sorted. Like you can sort your array, otherwise you cannot sort your array. So this is the first time you get the least element. This is the first position of the least element. Is it making sense? Yes, no. Okay. Now can anyone tell me what is the minimum number of operations? Let's say I'll give you an array, and this is your least element, like the first position, first position or first index, or the leftmost index of your least element. So what is the minimum number of operations?
Will be equal to the index of that least element.
Perfect. Index of that element, zero index, like starting from 0. So 3.
Yes.
So basically you have to do 3 operations. You have to shift these elements. You have to remove these elements from here. So basically 3 operations. And don't worry like how will the array be sorted, because these three operations are done in such manner that the array after these operations, if it is already sorted in this part, it will remain sorted, because this element will first shift here, then it will be kept on swapped until you find the first element which is strictly less than that element. So this will only stop there. So by default, these elements will be more than or equals to this element, and this will be strictly less. So that's why if this part was already sorted, the final array will also be sorted. So what you have to check, you first have to find the minimum element, then you have to find the minimum element, like the leftmost or the first position of the minimum element, and then you just have to check whether the array is sorted in this part or not. Is it clear? Okay, so let me show you the implementation. I think, okay, just give me a minute. I think, where is it? So in this, I have first taken n as input, then I have taken array as input. So this is the minimum element. Now this is the first position of the minimum element. Just iterate through your array. If ai is equals to minimum element, then position is I, and break your loop. If position is n minus 1, that means the last position is your, I don't think like this is also required. You can do it like this also. Just check like from position to a dot end, the array sorted. I've used an STL function. This is like inbuilt C++ function, but you can do this using a for loop also. So if this is true, just print your position, that is 0 index position of first occurrence of your minimum element. Otherwise, print -1. Is it clear? Okay, so let's go to the next problem. So in this problem, so Alex's birthday is coming up, and Timothy would like to gift him a tree of n vertices. However, Alex is a very moody boy, and every day for q days he will choose an integer denoted by an integer chosen on the ith day by di. Now, if on the ith day there are not two leaves in the tree at a distance di, Alex will be disappointed. Now we already know these di values, and we first have to design a tree, and then like what we can do on each day, we are allowed to do one single operation of following kind, which is choose vertices u, v1 and v2. And if there is an edge between u and v1 and there is no edge between u and v2, then remove the edge between u and v1 and add an edge between u and v2. So basically, see this thing. In this, u is 6, that is this thing, this vertex. v1 is 1, that is this vertex. And 6 is connected to 1, right? So you will disconnect this, like you will remove this edge and you will connect 6 to 4. That is this, you'll add this vertex. You'll add this edge. We cannot do this operation if after this operation the tree breaks. Like it is no more a tree. So first of all, let me explain this problem here. See, what you have to do, you first have to design a tree, and then for all the next q days or q queries, you are given that you want at least like there should be two leaves in the tree that have distance di. So you are given these kinds of queries. So for this, if the tree, like let's say this was your tree, and these two are already having like di was, let's say di was, for this day it was 3. So you already have three distant leaves, right? This and this. So then you need to print -1, -1, -1. Otherwise, if let's say di was, it was 4. So then you could have first removed this, like this. First, you could have removed this edge, then you could have added this edge, and now these are the two vertices. So let's number these 1, 2, 3, 4, 5. So this was the edge, or let me write it like this. So this was the tree. Now you are removing this. So your answer should have been like 5 was earlier connected to 3 and now it is getting connected to 4. So if di was 4, you should output this if this was your original tree. And if di was 3, then you can output this because there is already two leaves which are at 3 distant apart. After this, there will be two leaves which will be 4 distant apart, which is this thing, these two leaves. So first of all, is the problem statement clear? What we are required to do and what are the queries? First, design a tree and then perform these types of queries on that tree. Is it clear? Yes, no? Okay. Now this is a very simple problem. See, if we didn't had the privilege to design the tree, then the problem would have been a little complicated. But let's suppose I design this tree from 1 to n. Now, if I am given a query, right? If I'll always take this as one of my endpoints, this as one of the leaves, and this as the second leaf. So right now the distance is n-1. If this is the distance that I want, I'll print -1, -1, -1. If let's say I want 3 as the distance, so I'll connect the leaf to this leaf, I'll disconnect from here and I'll connect it here. If I want 4 as, if I want 2 as the distance, so I'll connect it here. I'll disconnect from here and I'll connect it here. Next time I want the distance to be 5, so I'll connect it here. So you see what I'm doing? I'm just connecting the node. Like if I want, like here I'll get 2 as the distance. If I want 3 as the distance, I'll connect here. If I want 4 as the distance, I'll connect here. If I want 5 as the distance, I'm connecting here. So basically, I'm connecting the node, leaf node, like this last node, nth node, to the node which is having the node which is having di as the number. Is it clear? Just connect this node to that node, and you'll get that much distance between first leaf, root node, and the last, that is n leaf. No, not root node to any node, but always di will be between root node and nth node, between these two nodes. I'll always make sure that di is the distance between these two nodes. So I'll disconnect this leaf from like this nth node from here and connect it to the diith node. So the distance between one and nth node is equals to di. Is it clear? Yes, no? Okay, so it's clear. So let me show you the implementation. Yes, root and nth node. So this is the implementation. First, just print a skewed tree, that is 1, 2, 2, 3, 3, 4. And then for each query, like right now, nth node is connected to n minus 1th node. So CON will tell me to which node the current node is nth node is connected. So if connected is equals to D, then just print minus 1, minus 1, minus 1. You don't have to do anything. Otherwise, print n. This is the node to which nth node was connected, and now this is the node to which it will get connected after this operation. Finally, connected is D. So is the solution clear? Like this is the node to which the nth node is connected. Now, so going to the next problem. So in this problem, we are given that, and so these two are just the definition of what a permutation is and what a tree is. Then we are given that Alex builds a tree from his constructor. So there is some tree that Alex has built consisting of n vertices numbered from 1 to n with the root at vertex 1. Then he writes down each integer from 1 to n in some order, obtaining a permutation P. After that, Alex comes up with Q triples of kind L, R, and X, and each triple he tries to determine if there is at least one descendant of vertex X among the vertices P, L to PR, that is in the range L to R in the permutation P. Now, so this is just a definition of what a descendant is. I'll explain this in a moment. Now, so we have to answer each of these Q queries. Now, first of all, see what we are given. There is a tree. Then there is a permutation P. So for each query, we are given L, R, and X. So in this, you have to just find if, let's say, this is a permutation. So between L and R, let's suppose this is L and this is R, and this is X. So you just have to find for any of these four vertices, like whatever there is in the permutation, is there any node here which is a descendant? Descendant basically means one of the child nodes, or maybe child of some other children node. So basically that node should be in subtree of X. So descendant of X, X can also be considered as a descendant of X by definition. So any node which is in this subtree is a descendant of it. So you just have to find between L to R, is there any node which is in subtree of X? So for every of these Q queries, we have to answer this. Is it clear? Yes, no, what we have to do. Now, see, How to solve this problem? See, if we perform a DFS, like a simple DFS on this tree, we can get, for each node, we can get what is the end time, when was the first time when this node was visited, and what is the out time, when was the last time when I exited this node. So basically, let me write down the value. So at time 1, this node is visited. At time 2, this is visited. At time 3, this is visited. At time 3, I leave this node. At time 3, I leave this node because I'm going just back. At time 4, I visit this node. At time 5, I visit this node. At time 5, I leave this node. At time 6, I visit this node. At time 6, I leave this node. At time 6, I leave this node. At time 6, I leave this node. Now you might be thinking, when I'm entering, I'm increasing my one. So basically, this is the general flow, but you can change this also. Like, you don't actually have to follow this exact thing. You can increment the time when you're leaving the nodes also. But like, it won't make much sense because 1 to 6 basically means that between 1 and 6, so basically you can get the number of nodes which are in the subtree of this node from these two numbers. So now what we can do, see, in this permutation, if I'm given L to R, if let's suppose the node was 1, this was the node, I could have just checked between L to R what is the minimum value. If that value was more than or equals to, like, these values are nothing but, let's suppose these are in time values, like from original permutation. Let me write. See, I have an original permutation P, right? So I have an original permutation P, and from this permutation I can make an in time, like I'll replace P of I with in time of P of I. So this is a new array which I have created. So for each node in, like, permutation I was nothing but, for each node there was a number for each vertex, right? There was, like, each of these vertices were jumbled in a manner. So now I have this in time. That is nothing but, for each of the PIs, I have at what time that vertex was visited, at what time this vertex was visited. So if I'm given L to R, and let's suppose I'm fixing my X as 1, I'm saying that it is the root node. So now L to R, if I have to check whether there is any node in L to R which is in subtree of node 1, what I can do, I can find the minimum of these. Why minimum? Because there is, why minimum? First of all, why minimum? Minimum because there is no other node which occurred before root node. There is no node which occurred before root node. So that's why I'm checking what is the minimum time or minimum time at which some node was discovered. If that time is less than or equals to the time at which I exited root node, then between L to R, then there is a descendant of node 1. So I can continue, I can say this logic for other nodes, other also. So let's suppose this is the node. If between L to R, there is a node which is, can I directly say this, that between L to R, there the minimum value is less than the ending time of this, then there is a node which is descendant of this node in L to R. Can I directly say this? No, right? Because let's say these are the visiting times, first time when the nodes were visited or discovered. And also I'll write the leaving times quickly. So for this node, let's suppose the permutation was having 1 here. So the in time or the discovery time is 1 here. But this doesn't mean that this node 1 between L to R, the minimum value is less than 9. So this doesn't mean that this node is having 1 as the descendant. This simply means that this node was visited before 5, because the entry, like the time I want between L to R, I want the minimum which is more than in time of node X. Is it making sense? If this value turns out to be more than, or like if this turns out to be less than or equals to the time at which you leave, let's call this as en time of X, then there is a node which is in subtree of X between L to R. Now, how to do this? Can anyone tell me? I want the node which is like I want the value. I want to find the minimum value between L to R in my new array, in my in time array between L to R, such that that value is more than X in time of X. How to do this? Hmm? No. Like if you do binary search will help you. First of all, this array is not sorted. That in time array won't be sorted. Okay, the values will be in random. Like this node is like the permutation is 1, 3, 10, 4, 2, 6, 7, and maybe the values will be like this node is visited at 1, this node is visited at 10, this node is visited at time 3, this node is visited at time 2, 6, 5, 4. So there is no point in doing binary search in this. And you are given L and R like this. And the current node is maybe you have 8 as the node, in time was 3. No, not in time is the number which is not here. Maybe in time was 7 and end time was 8. So now this is the kind of query. So you can do this using like the minimum, or in a range you can find using segmentary or Fenwick. But this is not even like this is doesn't even for Fenwick. This doesn't solve our complete problem. Why? Fenwick tree. Why? Because we also have to choose a value which is more than in of X. So how to do this? See, we visited our nodes in this order. First, this node was visited, then this, 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 and then this. So what we can do, we can process our queries. Like first, I'll take all the queries for this node. Then I'll take all the queries for this node. And when I'm taking queries for this node, I'll make sure that for this node, the value, like for this node, the value won't be 1 in this array. Like for first node, I will take something like 10 to the power 9. Like I won't consider this. Then for L2R, if I even have this node, like maybe if I even have this node, the minimum will be this only. I won't take this. Why? Because this node is now no more in any node subtree. I'm not considering this node. Then I'll find the answer for this node, and then I'll also remove this node. Then I'll go in this order only in which these nodes were discovered. Is it making sense? Because I want the minimum value which is more than n of X. So if there is no node which is like I'm removing all the nodes which were discovered before exit node. If I want to answer the queries for exit node, I'll remove all the nodes which were discovered before X. So how to do that? If this fourth node was discovered before 8, instead of 2, I'll replace this with 10 to the power 9. So if I have to take minimum of this range, it will be irrespective, like this won't be considered. Then I can take the minimum of this range and check whether or not that value is less than the time at which 8th node was left. If the value is less than ending of 8, then yes, there is a node which is a descendant of node 8. Is it clear? Like just process the queries in order of your discovery time of nodes. In that way, this condition, this more than en of X can be satisfied. And the minimum value, minimum can be satisfied, minimum can be found out using segmentary or Fenwick tree. Is it clear? Like, have you got the idea at least? Okay, it's clear. So let me show you the implementation. So see, first I'm taking n as input, then I'm taking q, number of queries as input. Then I'm taking tree as input. So this is the permutation p. Now, this is the DFS function in which I'll have the start time and end time for every node, and ORD is the vector which will have the order of nodes in which they are discovered using DFS. So this is a simple DFS function. Then these are my queries. Now I'm storing the queries for every node. I'm storing the queries. Query sizes in. So queries of I will give me all the queries for ith node. So L, R, and I also need the index, like the index of the query. Why? Because I have to answer the queries in that order only, in which I'm given, like the order in which I'm given an input. Now this is my answer vector of size q. This is my vals, and this is basically the position at which position the ith vertex is in p permutation. So first of all, since my complete implementation is like the first vertex is 0, I'm starting from 0, that is 0 index, and I have to decrease my pi by 1. So this is just making the input compatible with the implementation. Then position pi, the position of this vertex pi in like permutation is at ith place, and vals of pi is nothing but like initially for first vertex everything I'm including it like these values, right, at the time at which they were discovered. So vals of I is simply start time at which the this pith node was discovered. Then I have initialized my segmentary. Now for each of the vertices, I'm going in order of the discovery times. So first of all, this node was discovered, order of 0. This is okay. Then for each of the vertices, for each of the queries of vertex u, I have L, R, and index of that query. So I'll find the minimum between L and R. My answer for this index is yes, true if temp is less than the leaving time or the ending time of vertex u. Otherwise, it will be false. Then, once I'm done with each and every query of vertex u, I'll update the position of vertex u in vals array, right? In my segmentary with 1e9. Because now this node is not descendant of any node for any of the future nodes, right? Because all the other nodes in my order, DFS order, are visited after this node. So how can they be descendant? Like how can this node be descendant of those nodes? So that's why I'm updating this. Finally, for my answer vector, now these answer vector will have the order of all the like queries, answer like for all the queries in the order in which they were given to us in the input. So if E is 1, we'll print yes, otherwise I'll print no. Is it clear? Okay, perfect. Like I know this is a little lengthy solution, but the idea is very simple. Like instead of having following the DFS order, you can also follow the level wise order. But that will also require like that won't be also that straightforward. You'll have to also use some kind of logic to remove the nodes which are in the same level but are siblings. So, but yeah, this problem can be solved in that way also. But still, you'll require a segmentary or a fillet tree. So, thanks for joining, and bye bye. Yes, I'll provide all the code links. Like probably you'll can check from there also. I'll provide the complete solutions. Bye bye.